Namaskara. We will continue the discussions on finding a better split to get additional advantage and to get more efficiency in a divide and conquer algorithm. We were looking at finding min and max over an array of n numbers, and we are continuing our discussions here. What we have suggested is the following: if n is of the form 4k plus 2 split as 2k and 2k plus 2. In all other cases, okay, you split as floor n by 2 and ceil n by 2. Okay, in all other cases you split like this. So, if it is 40, it will be split as 20 and 20. If it is 42, it will be split as 20 and 22. An even number will be split into smaller even number, and that even number will be further split into smaller even number. In this way, the smallest even number being 2, an even node will expand only to will have only 2 as its children, 2 as its leaf. What about an odd one? An odd one will have an even number and a smaller odd number. For example, if you take 41, that will be split into 20 and 21. This will have only, that node when you expand it will have only 2's. This 21 will be split into 10 and 11. You can see that this is a smaller odd number. There will be one odd number that will have one even child and an odd child, but that will be a smaller odd number. This 10 will be split, it will not be split as 5 and 5, it will be split as 4 and 6. This 11 will be split as 5 and 6. So, this is the smaller odd number. 6 will further be split only into even, and this 5 will be split as 2 and 3. In other words, in the recursion tree, if there is an odd number, it will give rise to a smaller odd number, the other part will be even. That smaller odd number will give to another smaller odd number, which will with all other parts even. An even number will have only even smaller value. In other words, the recursion tree will have, at the leaf level, there is only one leaf with value 1. There will be only one leaf with value 1. All other leaves will have 2. Okay? Because there will be only one smaller odd number, the smallest odd number being 1, there will be only one node with, everything else is even. Take for example 19. 19 will be split into 9 and 10, right. Lower integral part will be 9, upper integral part will be 10, 9.5. So, (9) and 10. 9 will be split as 4 and 5. 10 will be split as 4 and 6. 4 will be split as 2 and 2, but this 5 will be split as 2 and 3. This 4 will be split as 2 and 2. 6 will be split as 2 and 4. It will not be split as 3 and 3. And this will be split as 2 and 2. So you see everywhere there is 1 3, this will be split as 1 and 2. So you see that there is all over 2, there is only 1 1. This is how the tree for odd numbers will look. The tree for odd numbers will look, when you look at the leaf level, there will be one leaf with weight 1, the rest of them are all weight 2, because an even will give rise to only smaller even number. So in general, if n equal to 2k plus 1, then this will have one leaf with weight 1, and it will have k leaves, all other leaves with weight 2. Okay? Therefore, if n equal to 2k plus 1, it will lead to one leaf with weight 1, there will be k leaves with weight 2. Therefore, there are k plus 1 leaf, there will be k internal nodes, k internal nodes. What is the total number of comparison? Total number of comparisons is equal to k internal nodes will have 2k comparison, k leaves will have k. This one leaf is 0, that is 3k. K internal nodes will have 2k comparisons. Each leaf with weight 1 will do one comparison. Therefore, the total number of comparison is 2k. But what is k? You can see that the so it is 3 k is floor n by 2, right. You can also write k as ceil n by 2 minus 1. Ceil n by 2, okay, n by 2, n by 2 is k plus half. So ceil n by 2 is k plus 1. So this is equal to 3 times ceil n by 2 minus 1, that is equal to 3 times ceil n by 2 minus 3. It is like n by 2 minus 3n by 2 minus 2. Because it is odd, I have taken the ceil n by 2 minus 3. So basically the complexity is 3k, it is n minus, okay, you can write 3k, also you can write as 3 times n minus 1 by 2, because k is n minus 1 by 2. You can also write like this, 3n by 2 minus 3 by 2. Three n by 2 minus 2. So T of n is 3n by 2 minus 3 by 2. N is odd, 3 is odd, so 3n is odd number. So 3n by 2 minus 2, okay, when you take upper integral part, it will add half to it. So, this expression is exactly minus 3 by 2, that is equal to CL 3 n by 2 minus 2. So, T of n is given by CL 3 n by 2 minus 2. When it is even, it is 3 n by 2 minus 2. When you take CL, you get the same value. This is for even. This is an integer, n by 2 is an integer. So, this is same as CL 3 n by 2 minus 2. So, in both cases you have the same expression. Therefore, you can write T of n as CL 3 n by 2 minus 2, which is just 3 n by 2 minus 2. In fact, for all even this is the expression, for all odd it will be one more. It does not matter. What is the net saving? The net saving is n by 2. Okay. The naive algorithm is 2n minus 2. This clever algorithm is 3n by 2 minus 2, a saving of n by 2. Definitely you are going to save n by 2, because there will be n by 2 2's. So, if n is even, you will save n by 2. If n is odd, you are going to save floor n by 2. You are saving k, which is n by 2, floor n by 2. In any case, you are going to save n by 2 comparisons, right. You can see the reduction here is n by 2, and this is saving of this represent 25%, because what is n by 2 to 2n? 1/4. What is the ratio between n by 2 and 2n? How much you are saving? 25%. So, if you split carefully, you can save further. That is what it says. If you split as n by 2 and n by 2, the saving will be 16%. But if you split n in the following way, what is the way you are going to follow? You are going to split like this: floor n by 2 plus CL n by 2 if n is not of the form 4k plus 2. And if it is 4k plus 2, you are going to split as floor n by 2 minus 1 and CL n by 2 plus 1 if n is of the form 4k plus 2. If n is of the form 4k plus 2, this is the way you are going to split. Okay. So, if n equal to 6, for example, floor n by 2 is 3, 3 minus 1 and 3 plus 1, it will be split as 2 and 4. For example, if n equal to 10, it will not be split as 5 and 5, it will be split as 4 and 6. floor n by 2 will be 5, 5 minus 1 and 5 plus 1. Okay. So, an even number will be split into smaller even number. They will be further split into smaller even number. So, an even number will finally have only 2 as leaves. An odd number will be split into an even number and a smaller odd number. That smaller odd number will be further split into even and a smaller odd number. There will be only one finally the smallest odd number, namely 1. Therefore, an odd number will be split in this scheme if n equal to 2k plus 1, this will have k leaves of weight 2 and 1 leaf of weight 1. If n equal to 2k, this will have k leaves of weight 2. There will not be any leaf with weight 1 at all, because n equal to 2k, okay, it will have only k leaves, each with weight 2 minimum. So, if you look at 12, which is split into 6 and 6, which is split into 3 and 3, 3 and 3, which will be split into 1 and 2, 1 and 2, 1 and 2, 1 and 2 in the previous one. This will have 8 leaves, but now 12 will be split into 6 and 6, but 6 will be split into 2 and 4, 2 and 4, 4 will be split into 2 and 2, so this will have only 6 leaves. This will have 8 leaves. Our new strategy will have smaller number of leaves. That is the reason why there is a complexity reduction. Okay? The complexity reduction is because of this. So, in general, if n is even, what will be the complexity? Let us say n equal to 2k, there will be k leaves. The complexity at leaf level is k times 1. There will be k minus 1 internal nodes. The complexity will be 2 times k minus 1. Therefore, the total complexity will be 3k minus 2. But k is n by 2, that is equal to 3 n by 2 minus 2. When n is odd, we have already seen the complexity is 3, seal n by 2 minus 2, just the next number. You take the same 3 n by 2, but take the seal and you will get that expression. Okay? Anyway, the net reduction is n by 2, whether n is even or n is odd. When n is odd, the complexity will be 3 n by 2, you take seal minus 2. The number of leaves with weight 2 is k, which is floor n by 2. The n equal to 2k plus 1. The number of leaves with weight 2 is k, which is equal to floor n by 2. Therefore, the savings will be floor n by 2. Always when n is odd or even, it is always floor n by 2. Okay? Therefore, we have the complexity like T of n is 2n minus 2, very simple algorithm. The worst case complexity is 5n by 3 minus 2. When you bottom out at n equal to 1 and n equal to 2, this is when you bottom out at n equal to 1. The recursion tree will be very big, but when you split even into even, the complexity will be 3n by 2 minus 2. This is when split carefully. So, how is the split defined? This is the way you are going to define the split. Okay? If n is not equal to 4k plus 2, q equal to floor n by 2. If n is not of this form, q equal to, this is a split point, q is the split point. If n equal to 4 else, q equal to floor n by 2 minus 1. Okay? So, this is how the split point is defined. So, now you are going to have two recursive calls. One recursive call is on a 1 dot dot q, another recursive call is on a q plus 1 dot dot n. You are going to make two calls. This is a split point. Earlier, q was always floor n by 2, but now if n is 4k plus 2, this is the split point, a1 to q. You are going to have an array. So, if n equal to 10, earlier you would have got a1 to 5, one recursive call will be made, a6 to 10, another recursive call will be made, right. Earlier it would be 1 to 5 and 6 to 10. But according to this strategy, this is of the form 4k plus 2, right. Therefore, you are going to have q as 4, 1 to 4 and 5 to 10. So, this will have 4 elements and this will have 6 elements. That is how we are going to split. And recursively. So, the number of items that you have, whether it is when you divide by 4, what is the remainder you get? If you get remainder 2, this is how you should split. If you are getting any other remainder, you split equally. That is, you use q equal to n by 2, therefore, the other part will be ceil n by 2. n is split into 2 parts. Okay? n equal to floor n by 2 plus ceil n by 2. So, this is q, therefore, this will be n minus q. the other part will have size ceil n by 2. Okay? Therefore, we summarize now. In general, when you are working with an array, we were trying to write pseudocode for array A P to R, A P to R. A P to R will have how many elements? R minus P plus 1 elements. R minus P plus 1 elements. If the number of elements divided by 4 leaves a remainder 2, then you split in one way, okay? Otherwise you split in a different way. Okay? You are going to define the split point by the size by 2 minus 1, okay, the size by 2 minus 1 if this is a multiple of, if it leaves a remainder 2. So, when you are calling APR, right, if R minus P plus 1 mod 4 equal to 2, then Q, the split point is R minus P floor, right, R minus P plus 1 by 2 floor minus 1, else Q equal to floor R minus P plus 1 by 2. You split as the number by 2. If this is the case, this is the special way to find the first half. Otherwise, the first half is defined by the size by 2. That is it. Okay? With this, you can work with the recursion. This is the way you find the split point for divide and conquer. You are going to split very carefully. That depends on the size. If it is any other size, split into lower integral part and upper integral part. Otherwise, you very carefully split with this strategy. Okay? This is how the general recursion work. So, we can write a pseudocode now. The pseudocode is min max A 1 dot dot n min max. Okay. So, if n equal to 1, return A1. If n equal to 2, you are going to compare A1 with A2. If A1 is less than or equal to A2, there are two elements A1 and A2. If A1 is less than or equal to A2, then min equal to A1, return A1 A1. This is the min and this is the max. Min is A1, max is min is A1 and max is A2. else min is A2 and max is A1. So, one comparison, you do this, else you are going to check, else if n mod 4 equal to 2, then q else if n mod 4, then q equal to floor n by 2 minus 1, else q equal to floor n by 2. After defining q, min max A 1 dot dot q min 1 max 1 min max A q plus 1 to n. This is the right half, min 2 max 2. So, you are calling recursively on A 1 to q, then you are going to call recursively A q plus 1 to n, which is q plus 1 to n. The first half min is min 1 and max 1, the second half min max is min 2 max 2. Now, you find the overall minimum equal to minimum of min 1 and min 2, max equal to maximum of max 1 and max 2. These are the two comparisons. So, 1 to q gives you min 1 and max 1, q plus 1 to n gives min 2 and max 2. Comparing these two, you get min, comparing these two, you get max, and return them. Return min max. The split point definition is important. The split point definition is important. If n is a multiple of 4 plus 2, then the split point is floor n by 2 minus 1. Otherwise, it will be floor n by 2. That is what is done here. So, this being a crucial step, let me write clearly here. If n mod 4 equal to 2, q is floor n by 2 minus 1, else q equal to floor n by 2. In other words, you can split n as n by 2 seal n by 2 if n is not of the form 4k plus 2, but you split as floor n by 2 minus 1 seal n by 2 plus 1 if n is of the form 4k plus 2. So, that n by 2 will be 2k, n by 2 will be 2k plus 1. Therefore, this split will be 2k and 2k plus 2. So, you can see that it is split into even smaller problem. Therefore, our third algorithm will have the complexity 3n by 2 minus 2. This algorithm will have complexity 3n by 2 minus 2. So, we will summarize. One algorithm, the naive algorithm has got 2n minus 2. The next algorithm has got 5n by 3 minus 2, and further improvement has 3n by 2 minus 2. This is 16% improvement, this is 25% improvement. So, by cleverly splitting you get additional mileage. So, when you have a divide and conquer algorithm, the question that you have to ask is, where do I bottom out? Should I split all the way up to trivial instance, or can I define the base cases appropriately so that I get a smaller recursion tree? That is one way of improving the efficiency. The other way is looking for a careful split so that you get further advantage. And you got a 3n by 2 minus 2 algorithm now. From 2n algorithm you have come down to 3n by 2 minus 2 algorithm. Now you can ask the natural question, is there any other split? I have found out one split, that is 3n by 2 minus 2. Is there any other split that can reduce it further? The answer is no. You can never increase it any further. Further reductions are not possible. Is there any other way in which I can bottom out and reduce it further? No. Whatever way you approach, it will take. Okay, further divide and conquer. Is there any other technique I can use it to improve further? The answer is no. 3n by 2 minus 2 is a lower bound. In other words, this is optimal. There is no way you can design an algorithm with a better complexity than this for solving this problem. In other words, we have got the optimal algorithm. The proof for optimality is challenging. It is very interesting. We will see that at a later point. Right now we are looking into the algorithm design strategy. Okay? So, min-max problem cannot be solved in less than 3n by 2 minus 2 comparisons. That means we have got the optimal algorithm in our process of discovering more and more efficient solution. This may not happen for many problems, but for this problem it so happened that we hit the optimal solution in our process of discovering more and more efficient divide and conquer algorithms. Okay? We stop our discussion on this particular problem at this point. Thank you.